Okay, so let's continue on with our exercises on partial sums of geometric and arithmetic sequences. We've been talking about geometric sequences, and in exercise 5, we want to find the sum of the first five terms of a geometric sequence with this given information. So we are going to apply our SN formula here in this exercise. And to do that, we just need to plug in an A1 and an R value. Oh, by the way, the sum of the first five terms, so we want SN, so S5. The language might seem a little bit different here. They don't refer to partial sum, but the sum of the first five terms is exactly what we would call the fifth partial sum. And according to the formula, that's A1 times 1 minus R to the fifth over 1 minus R in this situation. And just for the record, the geometric sequence that we're talking about here, you don't really have to even write this down, but it's AN equals A1 R to the n minus 1, right? So it's A1 is 1/2 times our R is negative 2/3 to the n minus 1. There's our A sub n expression. So you don't even have to write that down, but that's the geometric sequence that we're talking about. So let's plug in. A1 is 1/2 times 1 minus. Now I have negative 2/3 to the fifth power. I got minus a negative 2/3 to the fifth over 1 minus a negative 2/3. So one point of what we're doing here is just having a messy problem where we have to deal with quite a few minus signs all over the place. I have 1/2 times, in parentheses, 1. Now, this negative 2/3 to a power, we have an odd power, so it's going to have a negative result. I'm going to have minus a minus will become plus 2 to the fifth over 3 to the fifth. 2 to the fifth power is 32. 3 to the fifth power is, 3 to the fourth is 81, same as 9 times 9, so 81 times 3 is 243. But the main thing here is I want you to see that we end up adding. Now, if I had S6, or if I had an even power here, the negative to an even power would be positive, and we'd keep the minus sign for the subtraction in between. So it really hinges on whether we have an odd or even power, because we're raising a negative number to that power here. And then 1 minus a negative 2/3 is the same as 1 plus 2/3. And so I'm going to go through a little bit of this fraction mess with you. The 1 we want to think of as 243 over 243 plus 32 over 243, so common denominator, all over 1 plus 2/3 is 5/3. So I have 1/2 times 275 over 243 divided by 5/3. And so okay, so I have 1/2 times 275 over 243 times 3/5. And you can do a little bit of canceling here, because 5 goes into 275, 3 will go into 243, and so I think I end up with 55 over 162. decimal for that. That's about 0.3395. Just in case you go the calculator route. Okay, so, which I wouldn't mind at all. I just have a little bit of fun messing around with fractions. All right, so that's number 5. I think we can see it all there. We got a couple more problems we're going to do together. We're actually going to go back to working with summation notation a little bit. And in exercise 6, we want to find a sum. And maybe you can just look at exercise 7 there at the same time. These are both summation notation expressions where we want to find a sum. Now, we can always write out summation notation. We talked about this a few videos ago, where what this symbolism means is, since we're summing from k equals 1 to 12, you can take this expression and plug in k equals 1, then add to it what you get when you plug in k equals 2, k equals 3, k equals 4, all the way up to k equals 12. So there will be 12 terms to add up. That's fine. But we're looking for a bit of a shortcut here. We're going to try to make use of what we've just learned about arithmetic and geometric sequences. There's a mess of formulas that we have, and we got to be able to keep these straight. Mainly we need to be able to distinguish arithmetic from geometric. We have both sequence terms and the partial sum formulas, sequence terms and partial sum for geometric. So let's look at these problems now. What I want to focus on is what the look of one of these terms is in this sum. That looks like the form of an arithmetic sequence. So the arithmetic sequence is like an equals a1 plus n minus 1d. I can rewrite that 2 minus 5 times k minus 1 in the form 2 plus k minus 1 times a negative 5 is, we could call that a sub k if we wanted. There's no reason you got to use an n, or you could use another variable for your index like k. This is, we're finding a partial sum of an arithmetic sequence. So that's not always the case, but here it is, because I can see that my expression that I'm summing fits the form of a arithmetic sequence with a1 is equal to 2, and my common difference d is a negative 5. So notice we don't have a plus sign there, but we can think of that as plus a negative 5 times k minus 1. So, so this is going to be equal to, in terms of this arithmetic sequence, since we're adding from term 1 to term 12, the first 12 terms, this is equal to S12, where we use the arithmetic sequence formula. So S12 is, I'm copying from the formula, it's going to be N12 times A1 plus A12 all over 2. Okay, so I'm plugging into this formula. And I need, let's see, I got my A1, I got 12 times, A1 is 2. I need to know what A12 is, and so I got to figure that out here on the side. A12 is really what I get when I either plug in here or here, it's the same thing, with the index equal to 12. So that's going to be 2 minus 5 times 12 minus 1. It's just the last term being summed here. 2 minus 5 times 11. Now multiplication comes before it. Don't dare subtract here. That's 2 minus 55. which is negative 53 is a sub 12. So I have to add a negative 53, divide by 2. Of course, 2 goes into 12 6 times, got a little canceling there. 6 times negative 51. And when I multiply, I get negative 306. There's my sum, a negative sum. I got a lot of negative numbers I'm adding up for that problem. So that was an arithmetic situation that we were in. There's exercise 6. Now exercise, again, if I had added those terms up separately, which I could have done if I knew nothing except summation notation, I should get the same result. Okay, let's look at exercise 7 now. Find this sum. Now, notice here, I hope you recognize that what we have inside the summation notation expression, it looks like a geometric sequence form. A(n) equals a1r to the n minus 1. If I take this, write it as ak, my a1 is like 1/2, my r is like negative 3 to the k minus 1. So this is a partial sum of a geometric sequence. It's sort of another just challenge is just reading this abstract notation. And we can see that the a1 value is 1/2. The r value here is negative 3. And what we want, since we want a sum from k equals 1 to 8, we want S8. And we're in a geometric sequence situation, so we're going to use our SN formula, our sum formula for geometric sequences. So this is equal to a1 times 1 minus, I'm going to write r to the 8 over 1 minus r. The 8, because we're finding the sum of the first 8 terms. Let's see, a1 is 1/2 here. Times 1 minus, I got negative 3 to the 8th power over 1 minus a negative 3. Now, negative 3 to the 8th. Now, there's a negative number to an even power. So that minus sign is going to get absorbed, right? And I'm just going to, I'm tired of figuring things out in my head. 3 to the 8th is 6,561. Just what I would have thought. All right, 6,561. But now I'm still going to have a minus sign because this minus sign's gone, but the minus sign from the subtraction in the formula is still there. And yet down below where I have 1 minus a negative 3, that's going to be, maybe I'll write it out as just 1 plus 3 for emphasis. Because there we do have a double minus sign. So I got 1/2 times, I think that's going to be negative 6,560 when I do the subtraction, over 4. So that's negative 6,560 over 2 divided by 4 over 1, which is negative 6,560 over 2 times a fourth, or negative 6,560 over 8. And if I divide that out, negative 6,560 divided by 8, I'm getting negative 820, another negative sum here, because there's a lot of negative numbers involved for number 7. Okay, we got through this section, and I'm gonna bring these formulas just back up at the end of this video, because this sums it up. You know, in my course, you don't have to memorize these. I would give you these formulas, but you do have to know how to apply them. and know how to distinguish between arithmetic and geometric sequences. That's it.